Sharpen your pencils. It's time to do a little bit of math. We're going to talk about how we measure ventilation, the different metrics involved, and then how we use those measurements to specify the ventilation equipment for kitchens and baths. Let's start out with some definitions. Here we have two common measurements of the velocity of which air flows into a space. On the left, we have ACH, or air changes per hour. This measurement is typically used to measure whole house or continuous ventilation. On the right, we have CFM, or cubic feet per minute. It's more typically used to measure intermittent or local exhaust and for a specific fan or piece of equipment. The two terms are related and you can convert from one to the other. All right, if you have the CFM of the fans in a space, you can calculate the ACH, or air changes per hour, by 60 times CFM divided by the volume of the space. So let's go into some more detail about ACH, or air changes per hour. Conceptually, this is a measure of the air volume that is added to a space in an hour divided by the volume of that space. There's a range of typical air changes per hour, ACHs. We want a minimum of 0.35, all right, for healthy indoor air. A well-sealed new home will typically have somewhere around zero point 0.6. A reasonably tight older home might be in the 1.0 air changes per hour, and an older, loose, drafty home, like the one I grew up in, might have a ACH of 4.0. Moving to CFM, or cubic feet per minute, this is conceptually a measurement of the air volume moving past a single point within 1 minute. All right. The air volume moving past a point, you could think of it as air that's being added to a space, or maybe air that's being exhausted from a space, or even air that's being moved through a filter or a specific fan. All right. For example, in this illustration, we've got a vented range hood, and this fan right here, the air is moving through this fan at a particular CFM. Let's talk about sizing ventilation for your kitchen projects. For kitchen projects specifically, your hood CFM rating can be determined by the code minimum or NKBA guideline recommendation. It's possible that your cooking appliance will have a manufacturer's recommendation, but the best way to size your hood is to use the HVI recommendation. That's the Heating and Ventilation Institute. All right. And they have specific recommendations per the width of your cooking appliance, the location of it, and its BTU rating. So let's take a look at those. First of all, don't forget that you want to provide a canopy of at least the size of the range and preferably 3 to 6 inches wider on each side. This isn't just to capture the grease and odors from cooking, it's for the gas particles from your gas range that escape into the atmosphere. All right, the ventilation system needs to capture and exhaust these particles. So the recommendation is given per linear foot of range. So it's per the width of your cooking appliance. If the range hood is against a wall, you need 100 CFM per linear foot of range. If your range hood is in an island, you need more, all right? You have less efficient airflow and therefore you need more ventilation. you need 150 CFM per linear foot of range. All right, so those HVI recommendations were given per linear foot of range, but let's take a look at how they map up against some common hood sizes. So this table right here gives a width of hood, common hoods, 30 inches, 36, I know that says 30, but it means 36, and 48-inch wide hoods. All right. If you have your hood mounted up against a wall, here are the recommended CFM rates for these sizes, 250, 300, and 400. And again, you need to bump those air rates up if you are locating your hood over an island. Let's throw one more wrench into these calculations. The ventilation recommendations we just talked about are for gas burner outputs of less than 60,000 BTUs. If you have a serious professional gas range with a burner output of greater than 60,000 BTUs, you are going to need a slightly different calculation. All right, 1 CFM per every 100 BTUs. Finally, you can also adjust for some accessories like a griddle, wok, or fry basket. Add an extra 200 CFM, and again, go with the calculation for the higher BTU units. Let's pause here. You'll get a chance to practice these calculations during your in-class activities.